Finding a generic model for a digital twin would allow us to quickly develop support for new collaboration needs in the city. Instead of building a completely new application, we can simply add objects, concepts, and properties to the existing one. It's also beneficial if we, as users, don't have to learn new interfaces all the time, or at least have applications that build on the same principles. This is why, in this project, we are exploring how a generic interaction model in a digital twin might look. When computers were new and first entered the mainstream, their interfaces were abstract and unfamiliar to most people. To make them more intuitive, developers borrowed from the real world, introducing the desktop metaphor. This concept framed the computer interface as a virtual workspace, mirroring the physical objects and organization people used daily. Icons represented items like files, folders, and trash bins, while the screen became a desktop where these objects could be moved, opened, or organized. The goal was to bridge the gap between the complexity of computing and the user's everyday experiences, creating a sense of familiarity that helped demystify early personal computers. A digital twin can be seen as a continuation of this idea, but instead of drawing on the desktop for inspiration, it takes the world itself as the reference point. Creating a virtual representation of each object in the real world that we want to collect data about, understand, or collaborate around. These virtual representations of real-world objects allow us to analyze, alter, and interact with them in ways that go beyond the physical constraints of their real-world counterparts. The core concept of the digital twin is the objects. An object represents a part of the world that we recognize as distinct from the surrounding environment. It might be a building, a street, or a tree, but it could also include things that exist only in our imagination, such as real estate, city districts, and future elements that might not yet exist. On these virtual things, we can connect sensor data, relations to other objects and concepts, or store properties, key performance indicators, statistics, events, or user comments. The level at which we divide the world depends on the problem we are solving. For example, if we are city planners, the building might be the lowest level. However, for a real estate owner, a building or the real estate may represent the top level. To support collaboration between different stakeholders, we need to identify the objects and concepts that exist within the overlap of their spheres of interest. In this way, the real estate in the example is one such node that enables collaboration between, for example, city planners and real estate owners. In the current prototype, the user starts by logging in. Each user will then be connected to one or several collaboration groups. Each group has a number of scenes associated with it. A scene is a set of data confined in time and space, selected for specific collaboration purposes. Each scene has a number of layers. These layers can contain specific types of objects that can be toggled on or off by the user. For example, one layer might display development plans for the area, while another highlights innovative companies in the region. A timeline allows the user to view things as they were at a specific point in time. For instance, we can visualize traffic data captured from a traffic camera at a particular moment. We will also be able to see projections of the future. For example, we could visualize how these parking spaces are planned to be developed in the coming years. A scenario selector can be used to explore different possible futures. A bookmarking system allows us to create and share stories about the data, much like a PowerPoint presentation. In this example, we observe the changes in car emissions before and after people moved to the Stockholm Royal Seaport. Each object in the digital twin also belongs to a specific type, making the twin self-explanatory in terms of the concepts used within it. New objects and datasets can also be loaded through the data selector if the need arises. With this video, we hope you have gained some insight into the basics of how a digital twin could work, as well as how the diverse needs presented in the user journeys we will explore in the project can be addressed within the digital twin.